On the previous two slides, you saw paragraphs along with math terms and math tips. This next part of the lesson, we are going to chunk questions 2 to 5. Now, again, our main focus are conditional and converse statements. And then it also talks about, we're not going to focus as in depth on inverse and contrapositives, but I do want to talk about biconditional statements. And biconditional statements happens when you have both your conditional statement to be true and your converse to be true. If both of those things can happen, it can be considered a biconditional statement, which is written with if and only if. So here we've got problems 2 through 5. Again, I only want to focus on certain parts. So I want to focus on question number 2, question number 3, question number 5A, 5B, and 5E. So basically, we're omitting question 4, omitting C and D of question 5. So with your partners and your table mates, I want you to take the next, we'll go 7 minutes and see where we're at. So take 7 minutes, pause the video, and work on questions 2, 3, 5A, 5B, and 5E. As you can see, I've provided the answers for questions 2, 3, 5A, 5B, and 5E. Let's take a look at question number 2. It said, write a true conditional statement whose inverse is false. Now remember, inverse would be if not P, then not Q. So I wrote an example, but this did not have to be the answer you put. This is just an example. I put, if an angle has a measure of 95 degrees, then it is obtuse. The inverse of that would be, if an angle does not have a measure of 95 degrees, then it is not obtuse. Well, I can have obtuse angles that are not 95 degrees. You could have one that's 100 degrees, 115. All of those are still obtuse angles, but they don't measure 95. Okay? Number 3 said, write a true conditional statement that is logically equivalent to its converse. So, I started off with, again, you don't have to have this exact answer. If today is Monday, then tomorrow's Tuesday. That's true. But I could say, if tomorrow's Tuesday, then today is Monday. That's also true. Biconditional, when a statement and its converse are both true, they can be written into one statement using the words if and only if. An if and only if statement is a biconditional statement. All definitions we've learned can be written as biconditional statements. I took a look at 5A. 5A had the statement, numbers that do not end in 2 are not even. So it asked me to write this in an if-then statement. So I wrote, if a number does not end in 2, then it's not even. I said, well, that's false, because I have numbers that can be even that don't end in 2. We can have numbers that end in 0, numbers that end in 4, 6, and 8. So just because it doesn't end in 2 doesn't mean that it can't be even. Now, then it asked me to write the converse of that. And the converse of that would say, if a number is not even, so I put if this part, then it does not end in 2, this part. Well, if a number is not even, it cannot end in 2, because only even numbers end in 2. So this is a true statement. Part E said, can you write this particular statement as a biconditional statement for the original statement. Why or why not? Now, remember back up here, it said you can only write a biconditional statement if the statement and the converse are both true. The statement was false, the converse was true. So, because the if-then form of the statement and the converse are not both true, we cannot write this as a biconditional statement. If I wanted to, I could have written number 3 as a biconditional statement. It would have stated, today is Monday. If and only if tomorrow is Tuesday. One cannot happen without the other. Those would both be true. On to your debriefing question.